Hey, welcome to Facebook OpenBMC updates. So my name is Sai. This is Chris. So just a quick recap on the OCP summit, what we have been presenting in the last 3 years. So back in 15, we have the proof of concept for OpenBMC on the network system, like called Wedge, which is the industry's first white box switch. And then in 16, we have shown that we ported OpenBMC onto the servers, like Yosemite, which is our multi-host OCP system, and then storage system called Lightning. And in 17, we have ported it over to multiple other platforms, like and the storage, networking, and compute, different areas. And we updated the U-boot from 2013, which was we were using before, to 2016. And then the kernel was 2.26, and then we moved to 4.1 during that time frame. And also we have shown like last year about the security feature, like verified boot, so which is our way to kind of make sure the BMC is booting the known signed image. It was a proof of concept during that time, the last year. So I'll show what we are worked on in the last year for this summit. So we focus on 3 different areas internally. I would like to kind of take a step back and show like what areas we are working on internally. The first area is like working on OpenBMC as a firmware component. So which means like we create the binary that is needed for supporting all the features for a given platform. So we support a bunch of platforms. So make sure our team is working on the features that are necessary for making OpenBMC. And the second major component was infra integration. So which is like when we deploy these systems on multiple in the numbers like scale out numbers. So we had to manage them. Like the management means like it could be configuration or firmware updates or monitoring them continuously. So we'll cover details on the work we are doing on that front. And the last one is like creating a developer community, which I think Brad has spoken today morning. So that's what we have been working like last 8 months nearly to make that happen. So a couple of updates in the firmware component perspective, like what features we added and what updates were done. So one is the Python 2 to Python 3 migration. And then the Acto, we now, a couple of platforms were able to move to Rocco. And on the verified boot, we did a lot of work in this year to make it like production ready. So last year we have shown that there is a proof of concept code, but this year we had to do a lot of work on the hardware front as well as the software front to make sure it works in all kind of situations and then avoid the bricked systems because of the verified boot. And on the features front, we have the Yosemite V2 platform, which supports hard service. So previously, like Yosemite V1, we have 4 servers in a single chassis, a single sled. When we pull it out, we have to power off all 4 of them. But thanks to the hardware team, I think now the Yosemite V2 supports hard service, which means when you pull out the sled, it doesn't get powered off. So all the systems are running, and you can replace the component that failed, just that component, and put it back. So that support has to be added in the BMC, and that's one of the work we did in this year. And the other 2 features, like the LCD debug card and then at scale debug, I'll go into details in the next couple of slides. So LCD debug card. So this is a debug card that was announced in the last year. So previously, the debug card used to provide a postcode, a hex code. Now we added a LCD interface to that. So we get a lot of information for the debug purpose. So when a tech goes into the data center, so they get all the information that they need to replace a component or what happened bad in the last postcode that could cause some hang in the system. And also there is a bunch of controls to kind of power on reset or like a simple reset, console selection kind of switches. So this is what it looks like. So previously we used to have the original OCP debug version 1. We have a 9-pin connector. So in this case, it just connects to USB, so pretty easy to connect to the system instead of fiddling with the system and then go inside to kind of connect that 9-pin special connector. So this is how it looks like, the LCD debug card. So the debug card itself has a microcontroller, and it talks IPMB protocol to the BMC. So BMC and the microcontroller exchange information and display all the information that we have seen before. And next couple of slides, I will show like what information we can show, how it shows up. So a couple of debug pictures, like say postcode. So previously when we have some issue with the postcode, we just get like code like AD. So you had to look up into the data sheet and see like what that code means. So in this case, the LCD debug card will tell you like what happened in the last postcodes and where it got stuck. And the right side, the GPIO status. So this is another critical signals like proc hard. So we continue to monitor and then display the status on the debug card itself. And the critical sensors, like if something happens on the sensors, it shows up like what are all the temperatures or voltages for a given sensors in a readable format. And the system information, like all the part numbers, serial number, BMC versions, BIOS versions are displayed on a text format. The next major feature was at-scale debug, thanks to Intel. So previously, when we had to debug a system CPU, we need to go to the data center, connect a special blue box like ITP, pull the system out, connect that, and then reproduce the problem on that particular system. And with some of the system failures, they doesn't happen often or on a single system. So we had to kind of reproduce randomly. So in that cases, the at-scale debug feature helps us. So in this case, like the BMC will act as a remote agent where the C scripts or the debug code will run on a laptop on any internet or network connected. So where it talks to the BMC and the BMC has the backend connectivity to the JTAG to the CPU and get all the debug information. Now we'll move to the infra integration part.
Yeah, thanks, Sai. So we've had a number of different platforms over the years. Here they're not arrayed by time, but by class, like network, storage, compute, and also by what kind of BMC they have. Some of them don't have a standalone BMC. Maybe they have some management functionality through like a management engine. Others we included a third-party BMC on, and the majority, as you see, are we have OpenBMC running on them. And so I'll speak to monitoring the right side set of platforms there, performing upgrades on them, and configuring them. And so one of the challenges we face is the growing number and variety of OpenBMCs that we have deployed. So this graph over time on the x-axis and with a logarithmic y-axis kind of is meant to indicate the broad trends we have in our OpenBMC usage, and the lack of numbers is intentional. You can see we have a lot of some kinds of systems and a lot of variety as well. And in general, to kind of meet this challenge, we've experimented with a number of different approaches. But some of the approaches that have seemed the most versatile have been the ones that use the out-of-band functionality to kind of its fullest, and also that leverage the OpenBMC as a capable Linux system. Reusing, this is kind of a continuing theme. If there are existing usable, reliable, or open source projects that might be in use on the host, and we can reuse them on the BMC, that's a great win. So for monitoring, there are two categories that I would put the data into. We have numeric counters and we have strings. And for the counters, for the floats or integers, we have a REST API. It's implemented in Python, a little bit more monolithic than the github.com/openbmc1, and it exports these numbers, and it has strings too, but specifically for the number part, we have been able to periodically pull the whole fleet and put those data points into a time series database. About a year ago, we open sourced the core of that database as Baranjai on GitHub from Facebook, and so that's the database it goes into, and an example of some of the statistics that we store are like the image versions, what is everything running, and or how much free memory is on the BMC. And so the pie chart on the right is an example query and chart from version information data. And the one at the bottom there is an example of memory usage over time. And both of these are sort of in the memory situation here. Down and to the right for how much free memory there is not a great trend, something we would want to investigate. or having a lot of versions is, in this case, it was new hardware. And we're not sort of maintaining it like the production stuff yet. So the other class, other than numbers, is the strings. And right now we're running our syslog to export both the OpenBMC system logs as well as the serial console from the hosts, and be able to aggregate that together and look at information, not just one BMC at a time or one host at a time, but in aggregate. And something that I've kind of found is that the monitoring, being able to push updates, and the configuration can form a little bit of a virtuous cycle. And for example, the monitoring version information, we were able to use that for our upgrade process. But some of the other changes we made to the upgrade process to improve the resilience and the speed were writing more unit tests. With this number of OpenBMCs deployed, even if something happens a small percentage of the time, there'll be enough in absolute terms of that problem to make manual working around it a little bit annoying. So being able to make sure we actually handle the corner cases by writing unit tests has been nice. Also trying to make the upgrade process more stateless, idempotent, by checking all the time that all of the prerequisites have been met. We do have a few preparation steps that we need to run, especially on older versions, and making sure those happen successfully has, I think, helped us out. Also, making the upgrade process more independent of any sort of orchestration, running more code on the BMC that if, say, the SSH connection drops, can continue running, install a handler for the hang-up signal so that it just keeps going and has all the code to know what to do, has been helpful. And we had that in earlier generations of the upgrade code, and we've kind of done more of that. And also, yeah, like I said, taking as much of the code as we could and putting it onto the BMC at once, rather than trying to go back and forth over SSH for various steps, has also helped improve the resilience. We've also looked at, we've moved to using HTTP for and with a checksum validation instead of SCP for a bit of a performance improvement, and also that the availability of like load balanced HTTP servers and caching proxies is very nice, and you don't have to worry as much about having like local SCP executors or something. Yeah, like I mentioned before, that cycle of monitoring data helps with upgrades. Upgrades help. In the next slide, I'll go on to configuration. Here, just an example of some of the output from the current upgrade code. Doing all those checks, checking all the checksums to make sure that everything is intact. And so with configuration, we have explored a number of different options. And we have a chef-based implementation on network switches. It's been running for maybe over a year. I've also experimented with Ansible and was able to kind of demonstrate a proof of concept with that. But what I've been focused on for the past few months is how many working defaults can we include in the image that comes out of Yocto. For example, this NTP configuration, BB append, we just plopped in a NTP configuration file at build time that says NTP1, NTP2, NTP3, and with some DNS configuration information that DHCP delivers, the DNS search path that can resolve to like a local or regional NTP server, whatever the search path, that's kind of a suffix that gets appended to that NTP1. resolves to. That's provided a useful out-of-the-box default. We still have the option for changing it, but hopefully it'll work most of the time out of the box. We also, in some situations, kind of bootstrap using the Slack IP6 address. And so, yeah, that possibility of using a short DNS name where the DNS search path is kind of concatenated to some prefix to get the full host name has allowed us to have our syslog and NTP configuration out of the box. And we also occasionally use it for the HTTP, like the load balanced, or sorry, the caching proxies, the local instances of the caching proxy system. And those are a couple examples of the ways in which we've worked on configuration over the past year or so. And I've also been working on configuring OpenSSH more fully out of the box. And if anyone has questions about configuration specifics, I would love to chat about it. So I think next, I'm going to hand it back over to Sai to talk about our community involvement.
Thanks, Chris. Yeah, so the idea is to kind of use Linux as the tools that are available for Linux for OpenBMC, instead of reinventing tools just for the OpenBMC sake. So going to the next one, the developer community. So when we looked back, like as Brad mentioned, like 8 months, 9 months back actually when we met. So we looked around and then saw these two open source OpenBMCs, which are far apart. They're common in the sense like they use U-boot kernel, Linux kernel, and then the Yocto, but all other parts are pretty different actually. And then other than that, there are multiple private distributions. What I mean by that is like, say somebody took a snapshot of it and then they work on it independently, and then it is being used internally, not on the open source. So I personally helped like 3 or 4 other companies who want to kind of try it out on a different, their own hardware, which is pretty close to OCP hardware. So when we were chatting, we were looking like what we are all working is exactly same thing. We just want to do the same thing, same OpenBMC stuff over and over again in different companies. So how can we leverage each other's strength and then try to kind of come up with a unified source or unified distribution that helps across the industry. So that has been one of the goals that we started with. And then by this Monday, I think we have this Linux Foundation open source project actually, where we all can come together and then make this happen as a reality. So I think most of the details are covered by Brad. I think I'm not going to talk much on this slide further other than saying that it's the goal is there, and then there is a lot of effort that is being put in right now, and then we need to come together and then list out like whatever Andrew told, like the things that are coming up. We should work together, make them a reality. Thanks. Questions?
Any questions? Nope. Okay. Thanks. Thanks, Sai.
Thank you.